The chapter 4 slides up. This is the end of chapter 3, and here's chapter 4. All right. So this communication and network security. This is basically the Net Plus summary section of the course. And all right. So fundamental network concept, simplex is one-way communication, where it's like broadcast, no transmit at all, like receiving a signal and you can't send anything. Half duplex is where you can send or receive, but not both at a time. So this is the old walkie-talkies. You say, I have a message, over, then you stop talking and listen. You can only talk or listen, but not both at the same time. And most communication is full duplex, like in the real world. You can send and receive at the same time. Multiple people can be talking at the same time on the channel. All right, baseband is where the entire frequency ring is dedicated to one signal. That's the way Ethernet works. You have a cable, and that cable only connects two devices, and they can use all the electrical capacity of the cable. Broadband is what you have like FM radio, where there are many different channels, and each channel only has a limited bandwidth, so you can have many different streams of data sharing the available bandwidth. Analog is the old-fashioned technique where you just have a varying signal and it is carrying information, but it degrades with distance and degrades with external noise and so on. So you get some signal delivered, but it's not very controlled and it's not very precise. Digital signals use zeros and ones, and they can be sent with an error correction code, so you can tell when a transmission failed and retransmit. So by a process of detecting errors and retransmitting them, you can actually have 100% correct transmission. All right, then there's local area networks within a building, metropolitan within a city, and wide area networks is bigger, the largest one being the internet, covering the whole world. And there's also now the talk about the personal area network, which is all the devices you carry, like your headset and your telephone and so on, things you carry on your body using Bluetooth to have a short-range network. All right. So the internet is the global collection of all the networks running the protocol TCP/IP, which was chosen as the standard. An intranet is a privately owned network, typically limited only to the real employees of a company, and an extranet connects those private intranets, like connections to business partners. And this is often where you get in trouble. This is what happened to Target. Target got hacked through their heating, ventilation, and air conditioning company that had a connection to their network, and when they got compromised, they were able to go into Target that way and get in. That's the problem. All right. Circuit switching is the old-fashioned technique long before the internet, where you would have a circuit for just one connection. Now, you can still do it with a T1. Back in the old days, if you do long-distance calls, they had these telephone operators plugging you in, and if you made a long-distance call, you had one wire just for you. And only when you hung up could they move that one wire to somebody else, and there was a limited number of circuits. Now we're all using packet switching everywhere, where we have data packets that only use the wire for a brief period of time, and then a different data packet can go, so many people can share the channel. Now, the total amount of information it can move per second is the same, but many people can share that total. All right. You can have quality of service marks that cause certain traffic to have higher precedence, make other traffic wait. This is very important because voice over IP, people can hear about a 50 millisecond delay. So it degrades voice if you delay it more than that, whereas things like web pages and email can be delayed by a lot more, and it doesn't really matter, like a whole second. So it makes sense to give voice over IP traffic priority. All right, and the layered design makes it possible to manufacture hardware and software that can interoperate with other brands of hardware and software, by each device handling a certain limited portion of the work and passing it off in a standard format above and below. So there's two models that are common, the OSI model and the TCP/IP model. The OSI model is sort of from Europe, and it's sort of theoretical. The TCP/IP model is more a description of the way hardware is actually built. So the OSI model has 7 layers like this, and you have to memorize it with these phrases. You should certainly do that for the CISSP exam, and for that matter, the Net Plus exam and Cisco exams. So please do not throw sausage pizza away, is the common way. So at the physical layer, you have the cables and radio signals. Then you have MAC addresses at the data net layer. Then you have IP addresses at the network layer to transport data a long distance to the right location, and ports, TCP and UDP ports at the transport layer to specify which process on the destination machine should receive it. And these higher layers are typically all blended together into something like a browser to take the packets and assemble them into something that's meaningful to the human user. So I say this layer layer 1 you call the data unit a bit, and that's the physical media that carry signals and their devices like hubs, repeaters, and cables at this layer that do not have any intelligence. They just electrically repeat the signals without reading the address or making any decisions. At layer 2, you have MAC addresses, and you have devices that can tell the MAC address, so an Ethernet card can check the MAC address and decide whether to listen or not to that packet, whether it's my MAC address, and switches and bridges are the network connectivity devices that look at the MAC address and only forward the packet to the correct port to reach the destination. At that layer, they call it a frame, not a packet, I should say. Layer 1, they call it a bit. Layer 2, they call it a frame. And layer 3 is where they call it a packet. And anyway, layer 2 has a couple of sub-access layers called media access control and logical link control. And layer 3 is where you have packets and IP addresses. And this is what routers use, and this is what moves packets a large physical distance to get to the right location across the internet. Layer 4 is what determines which service will listen to it once it reaches the right physical computer, and these are UDP and TCP ports commonly. TCP is reliable. It checks to see if all packets have been received, and if not, it requests a retransmission to make sure they all get there. UDP is not reliable, and therefore it just delivers packets. It does not have any error correction or detect if they get lost. It just makes a best effort attempt to deliver them. So it's simpler and faster, but TCP is more reliable. The session layer is where you determine whether you have something established that's meaningful across multiple transmissions, like a login has been completed. And the presentation layer does things like remove encryption and compression and expand image formats so you can make them presentable to the user. And the top layer is the application layer for human readable data. This is where normal users live. They're an application, they're viewing a video or reading an email, they press a button, and they are not aware of what happens as that thing is broken up into packets and frames and bits and sent over the wire to the other person. But all that has to happen, and your engineering types like us have to understand all those intermediate steps that happen. But normal users just live at the application layer. I see the video, I see an email, I send my data, somehow it gets to the other person, but they don't really understand how many addresses and adjustments are going on to make it go there. So that's the heart of Net Plus. And let's just do a Kahoot, and I think this will be the last one for today. This is far enough. 4A should be, well, 4A should be available somewhere. There we go, 4A. Okay. Hopefully it doesn't have any 1-minute times. I guess we'll find out. Just wait for the end of the song. All right, so what transmission goes through an Ethernet cable? They are set for a minute. Now it said I could adjust it while it's playing. That would sure be nice. Ooh. All right, that's baseband. And really thought I'd be able to adjust it. Once again, this. Language, randomize. I'm only getting the global ones. Nope. All right, there must be another settings control somewhere I can't find. Oh well, such is life. That's baseband. All right, we'll put up with it, and after this I'll have to adjust it. I don't know how this happened, but all right. All right, what's the OSI layer with MAC addresses? That's what I thought. Okay, I cannot change the timing while it's running. That makes more sense. Okay. Okay. Yep, it's layer 2. All right. All right, where are the hubs? Layer 1. All right, and where are network file shares? Yep, they're actually layer 5, I think. Yeah, good. All right, because you have to like log in, just make sure you're allowed to view them. All right, Sylvie, all right. Okay, good. All right, let me stop this recording.